Okay, so now this is leading up to doing shell method to find another volume of revolution. And so the problem is that in the old one that we had that x is a function of y, or y was a function of x, and it was a one-to-one function. And so let's just let me just pull that up again. Negative x cubed plus 1. Okay. Now the thing about this function is that it passes the horizontal line test and it also passes the vertical line test. So if I sort of drag this down here, even though it sort of seems like it's all on a horizontal line, it's not. And so basically my little horizontal and vertical lines only cross once at one point. So this is a function of y and it is a function of x. This, on the other hand, is a function of x. It passes the vertical line test, but quite obviously it does not pass the horizontal line test. So right there, it does not pass. There's 1, 2, 3, 4 places where this crosses, that horizontal line crosses the function. So it is a function of x, it is not a function of y. Unfortunately, I want to rotate it around the y-axis. And so if you start to figure out what would be my disks, if I start to figure out, I'm going to do this. What does that do? That's what I want to do. Okay. So if I do this, if I want to break this up into disks, let me just sort of show you a little bit more about what I'm getting into. 0 is less than y is less than this function here. Okay, so I want to rotate this around the y-axis. And, well, in terms of how I'm going to do this in my graphing calculator, I need to do it around the z-axis. Oh, sorry, I want to do this. Boom. And I want to make this a 2. Okay. And so then here, there's my little function like that. Technically speaking, it's only that piece. It's only this piece that I'm rotating around the y-axis or the z-axis, depending on how you want to talk about it. So I'm going to take this little red piece and I'm going to rotate it around. And when I rotate it around, I'm going to get this sort of thing that looks like maybe it came off of a jet engine. Now, the problem is how do I cut this into disks? Because if I do this from, oh, how high does this thing go? I want to go 2.5. If I cut that from 2.5 to 2.6, I've got a disk, so I've got a disk with a hole in it. Well, that's, you might say, well, if you're really smart and if you've paid attention in calculus, you'll go, ah, that's washer method. I'm not going to really get into washer method right now. The problem is that the outside of the disk is defined by the function, and the inside of the the outside of the washer is defined by the function. The inside of the washer is defined by the same function. I'm getting into stuff that you guys don't know yet. Don't worry about it. So, for reasons related to the fact that this is a function of y, this is a function of x, but it's not a function of y, I cannot use my disk method. But what I can do is I can use this thing called shell method. And so I'm going to talk about shell method in just a second. Okay, I can't find a real easy way to do this on the graphic. So we're talking about volumes, a revolution, shell method. Okay, so I've got my little thing like this, and I'm going to rotate that around my axis to make a little bundt cake or something like that. And what I'm going to do is think about this. I'm going to call it soup can method. What you're going to do is you're going to divide this up into a series of cans. So you're going to take cans of different sizes and you're going to stack them inside of each other. So this is hard to see, but I've got a can here. Okay, so I've made a can, and the can has a height of f of x. It's got a, so the can, not car, can, has a height equal to f of x. It's got a thickness dx. It's got a radius equal to x. So it's got a circumference equal to 2 pi x. So now what I'm going to do is I'm going to take my can and I'm going to slice it along one side and I'm going to flatten it out to so I'm going to slice the can, I'm going to flatten it to make a slab. And that slab has dimensions f of x, 2 pi x, and then dx. So volume of slab is going to be 2 pi x f of x dx. So then total volume is going to be the integral of 2 pi x f of x dx. Okay, So my function that I just had my function f of x was going to be negative x to the fourth plus 2x squared plus 2. And we want to integrate that to 1 second here. It's some kind of, I just got to figure out what that integration point is. 1.65. Okay. So we want to integrate that from 0 to 1.65. And we got 2 pi x minus x to the fourth plus 2x squared plus 2 dx. Well, I'm just going to distribute this in. Two pi negative x to the fifth plus 2x cubed plus 2x dx. That's a pretty easy integral. I'm going to take that 2 pi and then I'm going to get negative 1/6 x to the 6 plus 1/2 x to the fourth plus x squared plus c. Evaluate that at 1.65 and 0. And I don't have to evaluate it at 0 because it's all just going to come out to be 0. So I throw it into my calculator and I get 2 times pi times negative 1 divided by 6 times 1.65 to the 6th plus 0.5 times 1.65 to the 4th plus 1.65 squared and then I don't have to worry about the plus c, and so I get negative 1.14.7. And I'm just going to take the absolute value of that and call it good. And that should be, I'm pretty confident that I just take the absolute value of that and it's 14.7. So the volume of the little bundt cake that I was showing you is 14.7. That's that video.